Greetings to everyone. I'm Dr. Mohammad Saad, and here is a little introduction about myself. I've authored six international publications, including my one international book chapter in the book Composite and Adsorbents, which was published by Elsewhere. My today's online lecture topic is about the periodic class. Before going deep into the lecture, let us have a look over some of the terminologies that will be used throughout the chapter. Periodicity means the repetition of any property at regular interval. It is termed as periodicity. Periodic classification is actually an arrangement of elements so that they can show periodicity. What's the purpose of periodic classification? It is actually to construct a periodic table. For example, if we take example of our books, if you are having more than 20 books, so it will be very difficult for you to find one particular book among all the 20 books. So you'll need to classify those books, or you need to actually sort them out in such an order so that you can get your desired book within 1 or 2 minutes. When you go to your library, the school library or college library or university library, you ask for a book by the librarian, and he actually takes 1 or 2 minutes and he actually gets you the book. So books are arranged there in a particular order. They are actually named, they contain shelves, and those shelves actually start with the particular alphabets, so that any book, if the name begins with A, it should be found in the shelf A. So same as that, when new and novel elements were being discovered day by day, chemists actually began to think that there should be some classification of those elements so that we can study them in a proper way, in a better way. So there arose a need of periodic classification of elements. Written history of periodic classification implies that by the 19th century, there were enough evidences about the properties of elements. So those properties were actually used to categorize them. And the first person in the written history was J.W. Dobereiner. This J.W. Dobereiner was actually working in the University of Jena, Germany. He observed that if we take triad of elements with the similar chemical properties, for example, if we take three halogens, chlorine, bromine, and iodine, and if we arrange them in increasing atomic masses, then the middle element would contain the average property of the extreme elements. For example, in this triad of halogens, chlorine, bromine, and iodine, the atomic mass of chlorine is 35.5 and the density is 1.56, and the atomic mass of iodine is 126.9 and the density is 4.95. Bromine possesses atomic mass of 79.9, which is approximately equal to the average atomic mass of the extreme two elements. The average of 35.5 and 126.9 is 81.2, and 79.9 is quite closer to 81.2. If you take a look at the densities of the two elements, the average of the densities is 3.26, and the density of bromine comes out to be 3.12, which means that it is approximately equal to the average of those two extremes. Now if you take a look at the triad of alkaline earth metals, there is calcium, there is strontium, and barium. The atomic mass of calcium and barium, when averaged, it gives around about 88.8, and the atomic mass of strontium is 87.6, which means that strontium possesses the average atomic mass of the extreme two elements. The same goes with the density of strontium. If you average 1.55 and 3.50, it will come out to be 2.52, which is quite closer to 2.60. So this is actually the classification of according to the Dobereiner. But this classification was not very popular because there were so many triads, and it did not apply to all the elements present in that time. After that, Newlands put forward his law of octave. He was an English chemist, and according to his law, if elements were arranged according to their increasing atomic masses order, every eighth element would possess the property similar to the first one. It is so because noble gases were not discovered then, but this theory was ridiculed by his own counterparts in the Royal Chemical Society, and they even refused to publish his research. However, he was awarded the highest honor of society for the periodic law, and it was the first time in the history that it was thought that the element could be arranged in a tabular form, in tabular fashion. So it was a great achievement, I would say. Dmitry Mendeleev was a Russian chemist. In 1869, he took a lead from Newman's Newland's law of octave, and he put forward his statement, according to which physical and chemical properties of elements are periodic function of their atomic masses. Actually, when he put forwarded his law, 63 elements were discovered till then. So he arranged all those 63 elements according to their atomic masses, and he observed periodicity. The characteristics of Mendeleev's periodic table are presented in front of you, and there were actually elements were arranged in the ascending order of their atomic masses. There were 8 groups and 7 periods in the Mendeleev's periodic table. Groups are the vertical columns, and the periods are horizontal rows in a table. So each group contains elements having similar chemical properties and physical properties. So what uh, there were some vacant spaces as well, which were left by Mendeleev, and he said that these are the places on which some undiscovered elements should be placed. So what were the advantages of Mendeleev's periodic law over other periodic table? Like I have earlier said that this periodic law was more complete, more comprehensive if we compare it with Newlands, and according to it, most of the elements show periodicity. He left vacant spaces for undiscovered elements. For example, uh, he predicted Eka boron, scandium 21. He predicted Eka aluminum, gallium, and he predicted Eka silicon, which is germanium. Eka means prior. Element comes before this, and not only for undiscovered elements he predicted, but he worked hard for some discovered elements too. He corrected atomic masses of some elements such as beryllium, gold, and indium. If we take a look at the properties of which were predicted by Mendeleev and which were actually observed by chemists, then we actually come to know that how well he is predicted those properties. Yes, yourself in the era of 1869, when there were no computers, there were no uh, laptops, there were no mobile phones, there were no sophisticated instrumentations, which means that it means that the weighing balances were not electronic also. They actually used to weigh by analog means. So how well he had actually predicted the properties of those elements. If you take at the properties predicted by Mendeleev of Eka silicon, which is actually germanium, he predicted that the atomic mass should be 72, and what was observed? It was 72.6, quite near to the predicted value. You can have a look at the color of the metal and all the properties which were predicted and were observed by uh, chemists. So it is just a fantastic, mind-blowing prediction, I would say. All is not bad when you perform something for a very first time. Then you actually leave some loopholes too. There were some disadvantages in Manley's periodic table as well. For example, there were no separate positions for isotopes. If we place elements according to their atomic masses, then there should be place for the isotopes also. For example, if we take a look at hydrogen, it contains three isotopes. It has three isotopes: protium, deuterium, and tritium. And according to the periodic law, they should be characterized differently because their masses are different. But there was no separate position for all these isotopes. So here's a problem. There were points. There were some actually. There were some places on which Mendeleev actually violated his own law. For example, he put forwarded, he placed argon before potassium. Argon has a higher atomic mass, 39.95. It should come after potassium, but potassium was placed before argon. Because of the similarity in properties of potassium with the elements, he placed potassium before argon. And similarly, nickel was placed before cobalt, and iodine was placed before tellurium. All these placings were made because of the similarity in properties. In some points, in some positions, he actually violated his own law. So this is a disadvantage of that Mendeleev's statement or Mendeleev's periodic table. He placed alkali metals with coinage metals. We know that alkali metals are highly reactive, and they tend to ionize very quickly, and coinage metals are very stable in nature. Therefore coins are made from these metals, and these metals have somewhat different properties, and they should be differentiated rather than putting them in the same group. So it is a disadvantage of Mendeleev periodic table. And another disadvantage is that there was no idea about atomic structure, and we have no clue whatsoever about the atomic structure of elements. So these are some of the disadvantages that we have from Mendeleev's periodic table. Now, by this we have concluded today's lecture, and after today's lecture, um after every lecture actually, I give some points to think. For example, our syllabus does not contain Laudermire classification, so I want you people to learn about Laudermire's classification. It was related to the atomic volume, but I need you people to study, and actually, if you find any difficulty, then comment. Then you should write it in comments. I will reply to your queries. And another question: in 1869, Mendeleev from Russia and Laudermire from Germany, both of them actually published periodic tables, but history remembers the name of Mendeleev. Why? I want all of you to answer this question in the comment section. So, by this, I conclude today's lecture, and I urge all of you to stay safe, stay home, and live happily. Good luck to everyone.